Why maintenance-free timing chains are killing modern engines. The $5,000 myth. You walk out to your car on a freezing Tuesday morning. You turn the ignition key and the engine fires up. But for the first 3 or 4 seconds, you hear a harsh, chaotic metallic rattling sound erupting from under the hood. Clack, 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 clack. Then, as the oil pressure builds, the noise mysteriously vanishes and the engine purrs normally. You ignore it, turn up the radio, and drive to work. You do this for a month. Then, one day on the highway, you hear a loud snap followed by a terrifying crunch of grinding metal. The engine dies instantly. You tow it to the mechanic, and they deliver a devastating verdict. You are maintenance-free, timing chain just jumped the sprocket gears, and your engine's pistons just smashed your valves to pieces. You now need a completely new engine, and the bill could easily exceed $5,000. You thought timing chains lasted forever. You are playing a dangerous game with marketing versus engineering. If you want to know what that cold start rattle actually is, and how to stop this impending mechanical death, keep watching. To appreciate the sheer violence of what happens when a timing chain fails, we have to look past the marketing literature and into the brutal heart of a modern internal combustion engine. Your engine is divided into 2 primary sections that must maintain a perfectly synchronized dance. The bottom half houses the crankshaft and the heavy pistons, moving violently up and down. The top half houses the camshafts and the delicate valves, which must open and close precisely to let air in and exhaust out. A modern engine is a mechanical orchestra playing at thousands of beats per minute. The synchronization between the pistons and the valves is critical. This synchronization is the singular job of the timing chain. It is a heavy-duty, multi-link steel chain that connects the crankshaft to the camshafts, ensuring that the valves are in the correct position for every piston stroke. We must now introduce a terrifying but necessary engineering concept that dictates why a failure here is so catastrophic: the interference engine. In the pursuit of higher compression, better efficiency, and more power from smaller displacements, almost all modern engines are interference engines. This means that the valves and the pistons physically occupy the exact same space inside the cylinder, just at precisely different times. When the piston comes up to the top of its compression stroke, the valves must be completely closed and tucked safely out of the way. They pass within millimeters of each other, thousands of times every single minute. If the timing chain loses its precise synchronization by even a fraction of a second, the orchestra crashes. The piston fires upward at immense speed and smashes directly into the open valves. The valves bend or snap, the cylinder head cracks, and the pistons shatter. In less than a second, your engine turns itself into a grenade. It is a total, irreversible, and catastrophic mechanical disaster. If the stakes are this high, and the timing chain is made of solid steel, why does it fail? Dealerships and sales brochures are quick to tell you that unlike rubber timing belts, a steel timing chain is sealed for life and maintenance-free. This is a carefully worded business strategy designed to minimize the perceived cost of ownership. While the steel chain itself is highly robust and rarely breaks, the system that keeps it running is incredibly fragile. A heavy steel chain spinning at 7,000 revolutions per minute does not want to run in a straight line. It wants to whip and thrash around inside the engine block like a dangerous snake. To control this violence, engineers must surround the chain with long, curved rails called timing chain guides. And what are these critical safety barriers made of? Plastic. Specifically, a high-temperature engineering polymer usually based on PA66 nylon. This choice is not arbitrary. Plastic is cheap, light, and friction-reducing. But it introduces a fundamental vulnerability. This is the central engineering paradox that kills timing chains. The nylon guides are subjected to extreme thermal cycling, heating up to over 200 degrees during operation and cooling to sub-zero temperatures overnight. This process, combined with exposure to hot engine oil, causes the polymer chains inside the plastic to slowly degrade through thermal oxidation and hydrolysis. Over tens of thousands of miles, the once flexible nylon becomes incredibly hard, then brittle, and finally, chalky. You have a violent, thrashing steel chain constantly hammering against a piece of plastic that is subject to brittle cracking and fragmentation. But the complexity does not stop there. As the steel chain and the gears naturally wear down over time, the chain appears to stretch. To compensate for this slack and keep the tension perfect, engineers use a device called a hydraulic timing chain tensioner. This is a small plunger that pushes against the plastic guides to keep the chain tight. It is a crucial piece of equipment. But here is the engineering reality that exposes the $5,000 trap. This tensioner does not rely primarily on a permanent, strong metal spring. It relies almost entirely on your engine's hydraulic oil pressure to function while the engine is running. The tensioner has thin, precisely calibrated internal passages that fill with oil. This pressurized oil allows the tensioner plunger to extend and counteract the chain's forces. Some tensioners also use a simple mechanical ratcheting system as a secondary backup, but the primary tension comes from the oil. And this is exactly where the $5 oil change kills the $5,000 engine. The critical murder weapon that destroys timing chain systems is dirty, contaminated engine oil. Many modern car manufacturers currently promote extended oil change intervals, sometimes suggesting 10,000, 12,000, or even 15,000 miles between changes. This is a calculated risk. While modern synthetic oil chemistry might chemically survive that mileage, the physical cleanliness cannot. The advertised oil change interval is a marketing strategy designed to lower the perceived cost of maintenance during the lease or warranty period. The manufacturer knows that the system will likely survive past 60,000 miles, at which point any catastrophic failure becomes the owner's financial problem. Over 10,000 miles of stop-and-go driving, your oil inevitably fills with microscopic carbon soot from combustion, water from condensation, unburned fuel, and fine metallic wear particles from all of the engine's internal metal components. This contaminated oil is pumped through those precisely calibrated passages inside the hydraulic chain tensioner. The tolerance inside these tensioners is exceptionally tight. The dirt particles in the extended life oil clog these thin channels, blocking the oil flow. The hydraulic tensioner loses its ability to maintain pressure. It becomes gummed up, and the primary tension force vanishes. Now let's go back to that freezing Tuesday morning. When your car sits overnight, the heavy oil drains down into the oil pan. The faulty, clogged hydraulic tensioner has zero pressure. You start the engine. For those first crucial 3 seconds, before the oil pump can force the sludge through the tensioner to build pressure, your timing chain is completely loose. It thrashes wildly inside the engine block. That terrifying metallic clack, clack, clack you hear is the heavy steel chain violently slapping against the plastic guides. This is the death rattle. Every cold morning you hear that noise. The steel chain is acting like a hammer, striking the brittle, heat-baked plastic. The constant impact weakens the nylon structure until, one day, the plastic guide simply shatters. Large chunks of plastic debris fall into your oil pan, where they get sucked into the oil pump pickup screen, restricting critical oil flow to every single moving part of the engine. Meanwhile, without the guides to hold the chain in place, the loose timing chain skips over the teeth of the camshaft gears. The synchronization is lost. The orchestra crashes. The piston smashes into the open valves at 3,000 revolutions per minute. Your engine is dead. This entire failure sequence is engineered for profitability and performance at the expense of long-term reliability. Automakers choose plastic guides and hydraulic tensioners to save weight, reduce friction, improve fuel economy, and lower manufacturing costs. The guides and tensioners are often buried deep behind the engine's front cover, requiring 8 or more hours of specialized labor to replace. They know that the system will almost certainly survive the factory warranty period. But when the tensioner clogs at 80,000 miles, it becomes your responsibility. So what is the survival protocol? How do you protect your interference engine from turning into a pile of expensive scrap metal? Here are the 3 actionable steps you must take to save your timing chain. Rule number 1. Establish a severe service oil change interval, ignoring the extended marketing recommendations. Dirty oil destroys hydraulic tensioners. This is your primary and absolute defense. If you drive in city traffic, short trips, or extreme temperatures, which is most drivers, you must change your high-quality full synthetic oil far more frequently than the factory suggests. Many experienced engineers recommend intervals closer to every 5,000 miles or every 6 months for these severe conditions. Clean oil flows freely and instantly pressurizes the tensioner the moment you turn the key, protecting the plastic guides from impact damage. Rule number 2. Never ignore the cold start rattle. Listen to your vehicle. If you hear a harsh, metallic slapping noise that lasts for 2 or 3 seconds during a cold morning startup, your timing chain tensioner is already failing. This is your warning sign. Do not turn up the radio. Do not wait for it to get worse. Have the hydraulic tensioner inspected and replaced by a specialist immediately. Spending a few $100s on a tensioner replacement today is the only way to prevent spending $5,000 on a complete engine rebuild tomorrow. Rule number 3. Always use the exact engine oil viscosity required by the manufacturer. Modern engines are highly sensitive to viscosity. If your owner's manual calls for 0-weight 20 oil, do not let a generic quick lube shop pour thick 10-weight 30 oil into your engine. Viscosity is essential for the timing of hydraulic systems. Thick oil flows extremely slowly when cold. It will take far too long to reach the hydraulic chain tensioner on a winter morning, guaranteeing that your chain will violently hammer against the plastic guides during every startup. The precise viscosity ensures the oil pump can instantly pressurize the tensioner and the engine's top end. To summarize the engineering reality of modern driving, maintenance-free is an engineering and mechanical illusion. Your steel timing chain is only as strong as the brittle plastic guides and the hydraulic oil pressure holding it tight. Extended oil change intervals are destroying these delicate hydraulic systems from the inside out, leading to widespread and early timing chain failures. A 3-second rattle is a warning of impending catastrophic mechanical death. Spending $50 on clean engine oil today is the only logical and engineered way to prevent spending a fortune on a new engine tomorrow. Do not let dirty oil destroy your vehicle's heart. Next time, we are diving deep inside the engine bay to look at the hidden, silent killer of modern engines. We will expose the hidden dangers of the PCV valve, and why a simple $5 piece of plastic can explode your main engine seals and cause catastrophic oil leaks. Subscribe if you want to understand how your car really works and how to protect it from the dealership's marketing advice.